Hello class, we are going to continue our lesson by learning how to find the equation of a line when it is parallel and then when it is perpendicular. Now, two lines are said to be parallel if I have a line L1 with gradient M1 and then I have a line L2 with gradient M2. These two lines are said to be parallel if they are moving in the same direction. So we are saying that two lines are said to be parallel when they have the same gradient. So two lines are said to be parallel when their gradients are the same. So suppose I give you a question. The line four y minus x minus 7 equal to 0 is parallel to the point a -1 -1 3. Find the equation of the line at A. Then I give you a second question. Number 2. The points -1 7 and Q 3 9 are parallel to the point R 0 3. Find the equation of the line at R. So assuming I have these two questions, the line 4y minus x minus 7 equal to 0 is parallel to the point A, -1 3. Find the equation of the line at A. Now, in my first question, in question 1, we are told that the line 4y minus x minus 7 equal to 0 out to the point A, -1 3. Now, we need to find the equation of the line at A. Now, for us to get the equation of the line, we also need to know the gradient. Now, since this line is parallel to this point, it means the gradient of this line is equal to the gradient at this point. So we are going to find the gradient of the line there. So how do you find the gradient? By making y the subject. So making y the subject, we have 4y is equal to x plus 7. So if we should divide through by 4, divide here by 4, here by 4, and then here by 4. We shall have y to be equal to 1 over 4x plus 7 over 4. Now, comparing this to the equation of a line, which is y equals to mx plus c, we realize that our gradient in this case is 1 over 4. Now, if our gradient is 1 over 4, we need to get the equation of the line at -1 3. So using the general equation of the line given 2 points, the one I gave to you earlier on, y minus y1 equal to m x minus x1. We are going to treat a being -1 3 as our x1 and y1 respectively. So using this and the gradient m, we are going to have the equation of the line to be. So we are going to use this and this. So y minus y1 is 3 equal to the gradient 1 over 4 into x minus 1. So this is y minus 3 equals 1 over 4 into x plus 1. We multiply 2 by 4. So 4 into y minus 3 equals to x plus 1. When we multiply here by 4, it will cancel out. So we have 4y minus 12 is equal to x plus 1. So 4y minus x minus 12 minus 1 is equal to 0. So our equation is 1y minus x minus 13 is equal to 0. This is the equation of the line at the point -1 3. Now we move to question 2. Now in question 2, it is said that the points P -1 7 and Q 3 9 we have the point P, -17, and the point Q, 39, are parallel to the point 03 of R. So find the equation of the line at R. Now, if these 2 points are parallel to this point R, it also means that the gradient of this line or the gradient of these 2 points is equal to the gradient at this point. So the first thing we are going to do is we are going to get a gradient of these 2 points. And earlier on, we learned that for us to get a gradient of PQ, gradient of PQ, it is given to us by y2 minus y1 over x2 minus x1. So if this is our x1, y1, x2, y2, our gradient is 9 minus 7 over 3 minus 1. So 9 minus 7 will give us 2 over 3 minus 1 will give us 4. So this will give us 1 over 2. So now our gradient is 1 over 2. Now using the gradient and the point R, the point R is what? 0, 3. Using these 2 points, using the equation of the line y minus y1 equal to m x minus x1, we can get the gradient of this line by using this gradient and then this point as our x1 and y1. So we have y minus 3 equal to the gradient 1 over 2 x minus x1 is 0. So this will give us 2 multiplied 2. We have 2 into y minus 3 equals to, when you multiply this by 2, you are left with 1x. So we have 2y minus 6 is equal to x. So 2y minus x minus 6 is equal to 0. This is the equation of the line. So with this, for us to get a line which is parallel to a point or parallel to another line, we just need to find a gradient. And the gradient, we maintain the same gradient and then we use it to find the equation of the line.